Hi, this is Matt McCormick. I'm in the Department of Philosophy at California State University, Sacramento, and this is the first of two lectures I'm going to do for my Inductive Logic course on Daniel Kahneman's book, Thinking Fast and Slow, and we're looking at chapters 26 through 29. So famously, Daniel Kahneman and Amos Tversky, who worked together for decades at several different academic appointments, devised a host of clever, very often gambling choices or clever problems that when you submit the problems to people, it reveals some really interesting nuances and bumps or ripples in the way they make their decisions. And the results of all this decades of research gets these guys the Nobel Prize, but it also overturns expected value theory and a host of assumptions that people were making in economics about the way humans reason. So rather than sort of talk about all this stuff on a really highly technical level and the abstract level, let's see if we can kind of induce some of the actual effects, the actual biases themselves, and then it gets into this discussion about what's the shape of human decision making in regard to the way Kahneman and Tversky set up the problems. All right, so suppose I give you this choice. Choice number A is I'm going to hand you $900. So you'll go from zero or whatever you got in your pocket to now having 900, or I'll give you the option. We'll do a gamble. I'll roll some dice, or I'll roll a dice or die or something, but we'll do a gamble where you get a 90% chance you'll get $1,000 or a 10% chance you'll get nothing. Okay, so given the choice between A, $900 for certain, or a 90% chance of $1,000, which one do you prefer? And the point here, I think, is to get system one engaged to sort of see Kahneman's point. Is to sort of feel what's your sort of basic intuitive or impulsive response. Do you want A or B? Most people, or very many people, statistically significant number of people, they like A over B. All right, that's interesting by itself for a bunch of reasons. So just keep that in mind, and let me give you another question. Okay, how about this situation? I'm going to offer you a new choice. You've got to give me $900 for certain. Just pull it out of your wallet and hand it to me, or we'll do a gamble, and in this case, there's a 90% chance that you have to give me $1,000 or a 10% chance you lose nothing. Now, which one do you like? Do you like C or do you like D? Which option do you prefer? Now, in this case, most people will say they prefer D. Okay, so there's a bunch of interesting things going on here. So first off, here's the first choice I gave you, A and B, 900 gain for certain, or a 90% chance to get $1,000 and 10% chance of nothing. And in that case, you preferred A, even though the expected value of A and B are the same. All right, so expected value theory tells us that a 90% chance of getting $1,000, well, you just multiply 1,000 by 0.9 and you get $900, right? So expected value theory says that choice B is worth $900. So if you were sort of strictly rational in a kind of cold and calculating way, according to the way expected value makes predictions, you would have no preference between A or B, but you definitely do have a preference between A or B. Most people prefer A. Okay, so that's important, and that's relevant to sort of debunking, or at least modifying our understanding of how people make their choices. Okay, so you prefer A even though the expected value is the same. You like that $900 for certain more than you like taking a gamble of getting nothing with regard to gains. Okay, first point. Second point is that when we flipped the case to losses, so now we're facing a $900 loss for certain or a 90% chance to lose more. Now you prefer D, even though the expected value of both of those are the same. So first point is that you've got preferences in both of these cases, even though expected value says that they should be the same, and you've got a weird, apparently inconsistent set of preferences. So you ignore expected value, at least your intuitions do, in the first case, and you have asymmetric preferences with regard to gains and losses. So in the first case, the choice of A or B, that's about gains. The second choice, C or D, is about losses. And when we bring up the prospect of losses, you get squirrely, you get nervous, and you're willing to be more risk tolerant. You're more risk seeking in the second case. Even though you're faced with the prospect of losing $1,000, that 10% chance of losing nothing in the D choice makes it appeal to you more, and it draws you to it. But actually, the prospect of losing of not gaining the $1,000 in choice B drives you away from it. Okay, so with gains, you're loss averse, and with losses, with gains, you're risk averse, and with losses, you're risk seeking. All right, so that's the asymmetry, and that's the sort of surprising result. We might be able to explain why it is that people prefer A and C together, or B and D together, or maybe that people have no preference, which is what expected value would have said, but in fact people prefer A and D, and they prefer it quite consistently. Okay, so that's weird and needs to be explained. We need to figure out what's going on there. Does that mean that humans are irrational? Does it mean that they systematically make the wrong choices in these kinds of cases? I mean, that's one question. And the other is, how do we get our theory about what humans do to match up with those outputs, right? People don't behave and don't choose according to what expected value says. Okay, so you're risk averse for gains and you're risk seeking for losses. That's the big point about this set of gambles that Kahneman and Tversky devised and subjected lots and lots of people to. Okay, so next. Here's another example that's designed to get you to feel the aversion to losses. So how about I'm gonna give you a series of gambles, and we'll ask, when would you jump off? When will you bite? When will you go for the prospect I'm giving you? So suppose we flip a coin, and if it's heads, then you got to give me $10, and if it's tails, I'll give you $10.02. Would you take that? Would you take that bet? Now, if you do the expected value on that, you realize, well, there's very little to be gained here. There's just a penny prospect to be gained in this case. So half the time I'm going to lose 10, and half the time I'm going to gain 10.02. That doesn't work out very well for me. What about this? 50% chance you lose $10, 50% chance I'll give you $11. Are you willing to take the bet yet? Maybe you're not. How about I keep up in the ante? Heads, you lose $10. Tails, I'll give you $12. Are you willing to play yet? My guess is that by the time I get to the last bet number 5 here, so now we're going to toss it, we're going to flip a coin, and if you lose, you got to pay me $10, but if you win, I'm going to give you $20. All right, that's looking really good. That's looking like that's enough to probably win you over. Now, some people will come over sooner, but the fact that it takes any movement up the scale here, right? So according to expected value theory, and if you were sort of really strictly speaking a kind of robot about making economic decisions and aggregating your decisions over the long term, you would have taken bet 1. But people will drag their feet until bet 2, bet 3, bet 4, and certainly by bet 5 they'll go ahead and do it. But you would have been making money if you had opted for bet 1, and if you had always opted for bets even as slim, where the positive margin is as slim as 1, if you were always making a decision according to expected value, you would have taken bet 1. And it took several more dollars. It took $9.98 more in the prospect of winning before you'd win over and come over to the bet 5. All right, so that's this. It's like an impedance. It's like a handicap. It's a weight. It's a drag on the way humans make decisions. They'll drag their feet when it comes to losing something. They don't like the prospect of losing. How much do they not like it? Well, in this case, they like it $10 worth. Like they really want to get a lot of gain in order to take on or accept the risk of loss. So you're feeling the loss aversion there if you're reluctant to take one of these bets until we get to bet 5. That's this thing, loss aversion, that Kahneman spends so much time talking about. Okay, so what's going on here? Well, loss aversion is this phenomena that owning something or having it or being faced with the prospect of losing it or having it taken away affects us more than the prospect of gaining it in the first place. Okay, so if you don't have something and you're maybe going to get something, okay, that's great. You love to get new things, you love to get money, you love to win, and you love to have that. But you treat that case differently than if you already own it, it's something that you possess, and now you're faced with losing it, opening your wallet and giving up money. That hurts you more. You're more reluctant, and you distort your decisions more in those cases than you do in the first cases. People expect more for a car they own simply because they own it than they would be willing to pay for it. Like if you ask people, when they go to put their car on Craigslist, they'll, maybe you'll look at the Blue Book value, but you always assume that your car's worth the most on the Blue Book value, or it's worth more because that was your special car and you had a name for it and you lost your virginity in it or whatever else happened. You've got all this attachment to it and you've endowed it with all this extra value. And that's this endowment effect of owning something makes you reluctant to give it up. One of the examples that Kahneman and Tversky talk about, or some of the research here gives an example of, take a bunch of attendees at a conference and you give half of them a coffee mug, or the other half you give them a tote bag at the beginning of the day, or some other kind of trivial but sort of equivalent gifts. And then you ask them to trade for the other one at the end of the day. And lots of people won't do it. That just because they've owned the thing and they've had it all day, it suddenly has this sort of attached new value to them. Just owning something endows it with a kind of magical weight. It's now become your precious. Okay, so when Kahneman and Tversky then worked out all the math and worked out a really a more detailed model for the way these tendencies emerge in people's decision making, they came up with this now famous chart which illustrates prospect theory. So their alternative to expected value theory is this new story that's supposed to describe human behavior. It's actually supposed to describe what rational behavior is. It's called prospect theory. So there's a lot of details here and a lot of things to capture, a lot of things to understand. So on the x-axis are just gains or losses, positive or negative. So on the left-hand side of the x-axis is losses and their value, and on the right-hand side of the x-axis are gains and their value. So that's the horizontal line across the middle of the chart. The vertical line, the y-axis, is the subjective or psychological value that you attach to a gain or a loss. So the vertical line is how do you feel about it, and the horizontal line is measuring just what is the gain or loss that you got. So if we were attaching exactly the amount of psychological value to something that's equivalent to how much it's worth, then you would expect to see that perfectly 45-degree line that goes exactly through the whole chart. That's expected value theory. Expected value theory says that if I'm faced with a chance of losing $5, a 50% chance of losing $5, well, that's equivalent to the, in terms of how bad it is, it's equivalent to how good it would feel to have a 50% chance of winning $5. So 250 gained versus 250 lost are treated the same in terms of how bad is bad and how good is good, and that would be the 45-degree line. So expected value theory has that line, but actual human behavior maps onto what Kahneman and Tversky have got here as the red and the blue lines. Okay, so there's a lot of things to notice here. First off, notice that the red line is curved and it goes down below the expected value line. Okay, so what that's doing is that's revealing or showing that loss aversion behavior that we already saw in those previous slides. That is, when I'm faced with the prospect of, losing 10 or losing 20 units, whether they be hours or dollars or whatever, I would, if I was a sort of strictly speaking rational, what Kahneman calls an econ, which is sort of it's a bit pejorative. The idea is that economists have been treating humans as if they're these rational, perfectly rational agents who make decisions according to expected value theory. Well, an econ would attach 10 units of disvalue to a loss of 10 units. Hence, you go down, you go over, you go left 10 and go down 10. But a human will attach whatever 15 units of unhappiness to a loss of 10 objective bad things, whatever they might be. That is, a human actually attaches more negative disvalue or disutility to something than its actual objective disutility. And that's what I mean. That's what I mean by saying that red curve curves down below the expected value line. We get too bent out of shape, or the prospect of losing makes us worry more, or we treat losses as greater psychologically than they actually are. So that's the loss aversion curve on the red. Notice that the blue line also curves, but it curves down towards, it's below the expected value line on the upper right hand corner, and it curves down to the right. Okay, so that means something interesting and important too. Okay, so first, the concave function, the red function, that's risk aversion, and we're risk averse. Oops, I got those backwards. The concave function is the blue line, and we're risk averse for gains, so we won't go out there and take on extra risk in those cases. But for losses, we will take on extra risks. And that's those examples of gambles we were looking at earlier. So we treat prospective losses as if they will hurt more than they actually will. And we actually treat prospective gains as if they will be less good than they actually are. And that's that blue line curving down below. That if I'm faced with an objective gain of 100, I will act as if, oh, that's only as good as getting 92. And I don't think I don't treat that, I don't give that proportional value to what it actually is for me. So gains are disvalued and losses are inflated in our heads with regard to their actual value. Now, the other point here is that both lines curve, and what that points out, or what that illustrates, is this idea of something called diminishing marginal utility. And it's actually a really simple idea. That, look, if you're looking at gaining $100 and you've currently got 0, then you attach a lot of value to that. But suppose you're already out there, you're a millionaire, and now you're looking at gaining $100. Or suppose you're broke and there's a $20 bill there on the pavement, and suppose you're a millionaire and there's a $20 bill there on the pavement. So if you're broke and you've got 0, that $20 means a lot to you. If you're a millionaire, you're a multimillionaire. If you're Bill Gates, you won't even bother to bend over to pick it up. That's too much time and effort. You've already made way more than that with your investments, and you can't be bothered. You light cigars with $100 bills, right? So the $100 bill for the billionaire is less valuable than the first $100 bill that you got. And that's the same goes for gains and for losses. So after a certain point, once we get out there to the limit, gains don't mean as much to us and losses don't mean as much to us. We just figure, oh, well, just pile it on. More's better, or more is worse, but whatever, I don't care. So, for really painful things, what's a little bit more waterboarding if I'm really miserable already? And for really fabulous things, what's $100 if I'm already a millionaire? I just don't care. I just don't put as much value on those as I did originally. So that accounts for the fact that both these lines curve. That's diminishing marginal utility, and so another deviation from expected value theory that we see when people make real choices. Okay, so the central tenets of prospect theory then for Kahneman and Tversky, there's several sort of complicated issues here. And one of them I haven't talked about yet is this one. Human decisions incorporate a neutral reference point or adaptation level that is set by expectations. That is, you get an idea in your head about something that's coming to you or something you're going to have to pay, and that sets your expectations, and that changes what you think is a gain or a loss or is a good thing or a bad thing. We might expect the status quo. We might want things to be the same. We might be expecting a gain. We might be expecting a loss. But whatever those expectations you have, those then contribute to how you evaluate subsequent losses and gains with regard to those reference points that you have in your head. And I'll explain that in a second with an example with Jack and Jill, and make it really clear what that neutral reference point business is about. I just explained diminishing sensitivity and diminishing marginal utility, that idea that the difference between, say, $9,900 and $10,000 is less significant to you than the difference between $100 and $200 in your bank account, right? You treat the initial, or wherever you are, you treat those nearby amounts as more valuable, whether they're gains or losses, and then the prospect of getting huge losses or huge gains way out there, those differences just don't count as much. So there's diminished sensitivity out there at the edges. Okay, so here's my example to illustrate the reference points issue. Imagine that today Jack and Jill both have $5 million. Okay, so what's that have to do with reference points? Well, suppose that yesterday Jack had $1 million and Jill had $9 million. So now reflect on their situations. Today, both of them are exactly the same situation. They're both $5 million. They both, objectively speaking, you say, that's fantastic. They're both worth a lot. They're worth the same. And they ought to be, I suppose, at least on expected value theory, they ought to be sort of the same level of sight. They ought to have the same, they have the same status, right? But when you realize the context, right, that where Jack was yesterday and where he is now, Jack is completely psyched that he's now $4 million ahead, and he's going to act accordingly. He's going to maybe act rashly, maybe treat that money kind of with less value. And notice that Jill, who now just lost $4 million, she's pissed. She had this expectation that she was a $9 millionaire, and now she's a $5 millionaire. So now she wants to get back where she was, or she wants the status quo, or whatever. Her expectations and her mental state and her the way she thinks about her situation is really different than Jack's, depending on where they were, what they were expecting, what was coming to them, what they lost. Are they equally happy? No, they're not equally happy. Do they have the same utility? Well, yeah, according to expected value theory, they've both got the same exact value. And notice it would be very hard for Jill to not have some sunk cost fallacy impulses here, or want to fix it, or want to act in a way that gets her back to her previous state, right? To regain the losses that she's gained. Whereas Jack is just psyched, and maybe he's going to be reckless. Maybe the first thing he does is goes and spends $500,000 on a Ferrari, whereas Jill wouldn't do anything like that. Even though she's got the same amount of money, she'd be conservative or careful or thoughtful to try to get her money back. Okay, so more central tenets from prospect theory to sort of get the details all worked out here. So we've already seen that humans are loss averse, and one short, succinct way to say that is that we disvalue losses more than we value comparable gains. Negative expectations are stronger than positive ones. This makes some sense in biological terms. Kahneman says organisms that treat threats as more urgent than opportunities have a better chance to survive and reproduce. And I'm going to come back to that in a minute. It has to do with negativity dominance, and it looks like there might be some good sort of evolutionary reasons for why our brains are built this way. And it comes up with regard to the question about whether we're being rational when we make those kinds of biased choices. Furthermore, in some cases, we're risk-seeking. That is, in bad choices where you're facing a sure loss, and you compare that to a larger loss that's merely probable. Diminishing sensitivity, he says, causes risk-seeking, and you'll get risk-seeking in those kinds of behaviors because you're looking at that possibility of not losing something. Maybe there's this gamble that there'll be a long shot, and maybe you won't lose anything at all. So you might think of that as kind of a status quo bias. That is, status quo bias is a preference that people have for keeping things the way they are. Don't mess with it. Don't change things. Even if my situation sucks, there's empirical evidence that shows that we have status quo bias. We like to keep things the way they are. And, there's a good question to be asked here about whether or not that's actually a mistake. From evolutionary perspective, look, if you're in a situation and it's stable and you're not currently dying, you're not currently on the verge of of dropping out of the gene pool altogether, then your situation's stable, and there's some risk associated with any change. There's some, any changing my situation at all raises new prospects and new risks and new bad things that might happen to me. So if I'm in a stable situation, it might make some sense from an evolutionary perspective to say, okay, stay put, don't move, don't change things, keep them the way they are, and look at the prospects of new gains, for instance. You deflate those a little bit because there's some risk associated with those. Maybe that won't work out. But losses, I don't want to have losses, because any loss moves me more towards zero, moves me more towards dead, more towards not passing on my genes to the next generation. Okay. And we've talked about diminishing marginal utility here, so I've got another slide. So I've circled now the curve on both of these lines that illustrates this diminishing marginal utility idea. The utility we derive from the first unit of some desirable good diminishes for each unit obtained thereafter, and the same goes for losses. The more of X we get, the less happiness you get from it, and the same goes for losses. Also notice that the losses curve drops below expected value theory. What does that mean? And we've said, the line's not shown on this chart here, but what we've said is that that's loss aversion. Humans feel more pain from a loss than they feel pleasure from an equivalent gain. So there's a lot of things going on in that chart. Also that for your preparation for the final, understanding Kahneman, being able to explain all this stuff, these are, this chart captures prospect theory, and there's a lot of things to explain here. You need to explain the curves, you need to explain diminishing marginal utility, you need to explain loss aversion, and how all that works in human choice making. Okay, so I said I was going to talk about negativity dominance. What that means is bad events, dangers, threats, perceived negative outcomes have a more powerful effect on our decisions, and they're weighted more heavily than comparably good positive events. So there's a quick and dirty way to define the term. I didn't check Kahneman for this. He may have cashed it out a little bit differently than that. You should go and see what he says about it in chapter 29. But that's a rough definition of it. What does it mean? Okay, well, he's got a great illustration. Look at these two sets of eyes. This is really perfect for getting to what he wants, getting to the point. Here's what Kahneman says. Your heartbeat accelerated when you looked at the left-hand figure. It accelerated even before you could label what is so eerie about the picture. The picture was shown to subjects in a brain scanner for 2/100ths of a second, and immediately masked by visual noise. So what that means is that none of the observers ever consciously knew that they had seen the pictures of the eyes. If you flash something that fast to somebody, they won't even be able to report on what they saw. But one part of their brain evidently knew. The amygdala registered the eyes on the left, and it has a primary role in dealing with threats or dangers, and the amygdala lights up when you flash the left-hand picture more so than the right-hand picture to subjects in a scanner. So there's lots of empirical proof here that shows it, but the idea is that fear wins out or has proportionally more effect on our decisions than hope. And that works really well for political campaigns too. We're in the midst of lots of people doing that. It's a good way to get yourself elected, is that you capitalize on fear and you dial that up in people, and that will have much more proportional effect on them than hope or optimism, because biologically we're built to worry about our prospects more. Being dead is much more threatening to us than the prospect of living, but living better than I'm living, or even twice as well as I'm living now. Okay, so the idea is that evolution favors bad news. We react to potential threats faster. We err on the side of false positives, where the positives are something dangerous to us. Bad news is worse than equivalent good news is good. So what does that mean? Well, good news is more food, more peace, more positive social events. Those are all good things, but they don't make a difference between my living and dying or passing on my genes or not. I mean, more food's good, but that's not the difference between, my kids making it not, if I'm currently in a status quo situation that I can survive in. But bad news, that's bad. Loss of food, dangers, threats, hostile social situations, they're all bad, and they could make the difference between living and dying. So those we pay attention to, those we worry about a lot. I don't have some of the data here, but when you look at the polling data for like the last presidential election in the United States, and you look at what people were worried about, and the odds of your being the victim of a terrorist attack or something like a tiny fraction of a percent, but you got people saying, you got 40 or 50% of the population saying they're really worried about being the victim of a terrorist attack. Meanwhile they're eating food that's been left out on the counter, and it's got botulism in it, and they're engaged in all kinds of activities that are way orders of magnitude more risky, but they're afraid of terrorists, so they act accordingly, and they sort of skew their decisions accordingly. So it looks like natural selection built our systems to be skewed in favor of noticing bad news. And I've suggested that maybe negativity bias is rational, or maybe it makes some sense if we're talking about the difference between, living and not living, surviving and not surviving, that good cognitive agents ought to always bias or inflate the prospects of losses or harms or negative things, and treat those as a bit more dangerous than the equivalent gains, because those have more potential to do more harm to me in the big picture. One way this got put, and I forget who said this originally, it wasn't Kahneman, a single cockroach will completely wreck the appeal of a bowl of cherries, but a single cherry will do nothing at all for a bowl of cockroaches. And I hope you're looking in that bowl of cherries for the cockroach. Okay, so let me just summarize what we've hit on now in this first part of the lecture. We've talked about loss aversion, and I've illustrated a couple of different ways to show how that comes out in us. The endowment effect is this idea that when you get something, it gets endowed. When you own something, when somebody gives you something and you possess it, now it's been endowed with extra value. So loss aversion and endowment effect go together. Prospect theory is that great big chart, that there's 4 quadrants that show those curved lines that deviate from expected value theory. Diminishing marginal utility is the bending of those curves, and negativity dominance is this idea that the prospect of harms or disutility or things that might hurt us, those dominate and have disproportionate value over things that might benefit us. Okay, so in the next lecture, I will finish up this discussion of Kahneman chapters 26 through 29, and next week we will wrap up Kahneman's book and do chapters 30 through 38 and put the whole thing together.